Okay, here I'm just going to run my physics project. Okay, so as you can see, there's 10 spheres bouncing around against the planes. I'll get rid of this later. As soon as they go to a certain distance off the screen, they come back on, so they'll never actually stop coming back onto the screen. As you see, they do contact with each other. Sometimes they freak out a little bit and get stuck in things, but such is life, I suppose. Yeah, so let's look at the marking scheme. So all this was pretty much free, except for this. I'll show you that in a minute. So there's 10 spheres. The sphere-sphere collision detection is done. So actually this is this part. Spheres interact with spheres with no collision detection, or with both collision detection and at least somewhat realistic response. So they do respond to each other. The collision detection is there. The environment is defined by flat boxes that are made up of triangles. So when the spheres collide, they do collide with the triangles and not just the planes themselves. And the response, as you saw, well, we can just go back to it. It's still running. Yeah, they bounce. Sometimes they get stuck because I'm randomly, when they fall off, I'm randomly generating a spot where they come back on. So sometimes they'll randomly generate inside the wall. So for controlling the first object, if I just hit enter, it comes back to the middle of the screen, and I'm holding my left key, left arrow key, and you can reverse the velocity on the x-axis in a negative direction. And if I just reset it again, I can increase the velocity going downwards by pressing the down arrow key. I can also increase the velocity going upwards, which is kind of hard to tell. I'll reset it again. So there's going up, there's going down. I'll reset it. That's on the x-axis. And then it's changing color because there's different colored lights in the scene. And that's I didn't let you control the z-axis because it would just fall off the screen, and then yeah, it would be pretty pointless. So there's that. I did this part, some or all the dynamic environment is not axis aligned. So there's that one and that one, but I skipped the middle part. I don't know if that counts at all, like if that's gonna be worth 110% because I didn't do this part, or if I had to do this part in order to do this part. Not really sure, but I did it anyways because it was super easy after I got all the environment collision happening. So what else was there? Oh, I can move the camera. I can move the camera away from the scene, towards the scene, move it to the right, move it to the left, move it up, which is actually a pretty interesting way to look at it. Yeah, so there's all the movements. So the simulation is discrete. The layout of the scene is described in an external file. I can show you that. So this is where all the magic happens for the scene. There's all my lights. There's all my models. So this one right here, this is the model that you're going to be controlling, so you can set it to wherever you want, whatever color you want. I just set it to almost white, just to stand out so that you knew which object it was. I could increase the size as well if that helps. But then when you increase the size, you have to increase the radius because they're equal in this case. So there, that's this huge, oh jeez, it keeps colliding with everything. Okay, there we go. So it's huge. I can reset it again. It's kind of hard to see because there's no light directly in that spot, but as soon as you move it, it does move around and stuff. And you can get it unstuck off of the walls, which is pretty cool. It's not unsticking. Oh, there it goes. Alright, so that was just to demonstrate that you can change this and it actually directly affects the scene. And I think I've shown everything that was required here. Yeah, I just didn't do this part because I was running out of time. I still have to do another project, so that's my video.